Hi everyone, in this video we are going to be talking about continuity. So continuity is something that we use to describe functions. It's a characteristic of a function, and our goal is to be able to identify functions that are continuous or discontinuous. So for example, if you're taking an exam or the AP test, they would ask you something like, is this function continuous? And you would respond yes or no. So it's a characteristic of a function. And our goal throughout this video is to be able to identify when functions are continuous and when they're not continuous. So the first thing that we're going to talk about is, what does continuous mean in a mathematical sense? And you might have an idea of what it might mean just from the word, and your idea might be right. And so an informal definition for continuity means that you can draw the entire function without picking your pencil up from the paper. So what I mean by that is, say you need to draw the function y equals x, okay? We know that y equals x is just a straight line that goes through the origin. So if I go to draw this function, it's gonna look something like this, okay? So that line that I just drew, was I able to draw that whole line without picking my pen up from the paper? And well, yeah, it was just one motion, right? I was able to draw the whole thing without lifting my pen up from the paper. And so that is kind of an informal way of figuring out if a function is continuous or not. And so then, they might be wondering, well, are all functions continuous? I mean, what would a non-continuous function look like? And so what if I had a function that looks something like this? So it has a little hole right here. Do you think that would be continuous? Well, the answer is no, right? Because if I'm drawing this function, I draw this little piece, then I have to pick my pen up from the paper and then continue drawing this piece, right? I can't draw the whole thing in one motion because there's that hole right there. I have to pick my pen up from the paper and then keep drawing. So this function is not continuous because there's this hole or this gap, this problem in the function that stops me from being able to just connect all the points in one smooth motion. So I think this definition right here in blue, while it's not like a precise mathematical definition, I think it's really intuitive, and it's easy using this definition to kind of get a sense for if something's continuous or not when you're first learning it. So I think the best thing with continuity is just to do a bunch of examples and look at when is something continuous, when is it not. So right here, I have an example that's really similar to the one we just looked at. It has this hole right here. And this function is not continuous because if I tried to draw it, I would have to draw this piece, lift my pen off the paper, and then draw this other piece, okay? So this function is not continuous because there's that hole that kind of interrupts the function. We look at this one right here. Let's see, can we draw this whole function without picking our pen up from the paper? Well, it looks like this function has a vertical asymptote right along the y-axis. So if I were to draw this function, I would have to draw this piece on the left, pick up my pen from the paper, and then draw this piece on the right, right? These two pieces on the left and right aren't connected. There's a vertical asymptote between them that kind of separates them. So this is not continuous because the function's interrupted by the vertical asymptote between these two pieces. We can't draw the whole thing with one smooth motion. And then what about this third one right here? Well, the function has a hole right here, but the function's still defined at that point, right? This point right down here is saying that the value of the function right here, the y value, is the y value of this point. So the function's defined there, but is it continuous? Well, if I'm trying to draw it, I draw this piece, then I have to pick my pen up from the paper, draw this circle, then I have to pick my pen up from the paper again to draw that piece. So this function is definitely not continuous because I can't get all those pieces and the dot. I can't do that all in one motion, right? I have to lift my pen off the paper in order to draw all of that. So it is not continuous. So hopefully that gives you kind of just an intuitive idea of what we mean by continuous. And, it's very related to the word continuity, right? Continuous, something keeps going, it doesn't stop. That really is kind of what we're getting at here, is whether or not this function continues in a nice, smooth manner. Okay, so that's the informal way of looking at it. But for this class, we want to talk about the formal definition of continuity. And it's really important that you know this for the AP exam. So the formal definition of continuity says that a function f of x is continuous at some point x equals a if all of these three conditions are met. So the first condition is that f of x has to exist at the point x equals a. The limit of f of x as x approaches a also has to exist. And then the limit of f of x as x approaches a has to be equal to f of a. So this is the formal definition, if you want, of continuity. And there are these three rules, basically, that you will want to check every time you're assessing whether or not a function is continuous, okay? So if on the AP exam, they ask you, is this function continuous? You're gonna look at these three criteria and you're gonna have to check them all off. If you can check them all off, if you can say yes to all of them, then this function is continuous. And so I think it's really important that you memorize these three conditions because on the AP exam, oftentimes they ask you to justify your answer. So they might say, is this function continuous? And justify your answer. So if the answer is yes, it's continuous, and you just say something like, I can draw the whole thing without lifting my pen up, that is not going to get you full points because that's not like a formal, rigorous definition, okay? If they ask you to justify if something's continuous, it is these three things, these exact three things that you should talk about. So let's go into each of these in a little more detail. So the first condition, f of x exists at x equals a. What does that mean? Well, this just means that when you plug some number, some x value into your function, you get a number out. Seems simple enough. But you might be wondering, okay, well, when is this not true? What's an example of a situation where f of x doesn't exist at a? And so one example is something like this. Okay, so this function I've drawn, right at x equals a, it has a hole, right? And that hole means that the function doesn't exist there. There is no y value that's defined for the function at x equals a. So this is an example of a function that is not continuous, and it's not continuous because f of x does not exist at x equals a. There's no y value we can assign to that point at x equals a, okay? So if there's a hole in the function, then it is definitely not continuous. Let's look at the second condition. The second condition is that the limit as x approaches a of f of x has to exist. And so as a refresher, this means that what I call the overall limit has to exist, and the overall limit exists when the left and right hand limits agree. If that sounds kind of weird or unfamiliar to you, then go back and watch my videos on limits, because we talk a lot about left, right hand limits and overall limits. So go back and watch that if you need to. But that's what this condition is saying, is that the overall limit needs to exist. This is another condition that has to be met in order for something to be continuous. So what's an example of where this case wouldn't be met? What's an example where the limit does not exist? And an example might look something like this. So this function, let's say that's a right there. This function does not have a limit as x approaches a. Why? Because the limit as we approach from the left is going to be right here, but the limit as we approach from the right is going to be up here. So the left and right hand limits for this function are not the same. They don't have the same value. If the left and right hand limits don't have the same value, there is no overall limit. So condition 2 is not satisfied. And then the last condition, the limit as x approaches a of f of x has to be equal to f of a. So this means that the value of the limit, whatever that number is, and the y value of the function at that same spot, they have to be the same number. So this one's a little tricky, but I think, again, the best way to see this is an example where this case is not met. So maybe I have a function that looks something like this. And this is a, and let's just say this is maybe 5, and this is 7. So what's the limit of this function, f of x, as x approaches a. What's the limit? Well, the limit as x approaches a of f of x is going to be 5, right? Because as we approach from the left and as we approach from the right, the y values are approaching 5. So that is 5. Okay, but what is f of a? When I plug a into this function, what is the y value that I get out? Well, if I plug a into this function, the y value is dictated by this point up here. The y value is 7, because this closed dot right here is saying that that closed dot represents the function value at that point. So there may be a hole down here, but the function is still defined at x equals a. It's defined by that single point at x equals a. So the function value is 7, but the limit as x approaches a is 5. Those two things do not agree, right? 5 and 7 are not the same number. So that means condition 3 is not satisfied. The limit and the y value of the function are not the same. So this function right here that we've drawn is not continuous. Okay, so hopefully that makes sense to you. I think with these problems, it's really just doing some practice and making sure you memorize those 3 conditions. Okay, every single time you do a continuity problem, every time you're asked, is this function continuous or not, go to those 3 conditions and go through each one of them. You have to be able to say yes to all of them in order for a function to be continuous. If you say no to even just one of the conditions, the function is not continuous, okay? So don't try to just, look at the picture of the function and kind of just decide in your head whether it's continuous or not. Use those 3 conditions every single time you do these kinds of problems. And so really quickly, I just want to mention just some kind of language things that I think might be kind of confusing if you're learning this for the first time. So sometimes you will see questions asked, is f of x continuous at x equals 4? So they give you a point at which they want to know if the function's continuous. And sometimes they might ask, is it continuous on an interval? And so there's really nothing new here. If they're asking if the function is continuous at a point, go through those 3 criteria. Look at that point on the function, go through those 3 conditions that we just talked about. And so in this example, if we look at x equals 4 is right here. There's a hole there, right? And we just talked about how if there's a hole, the function's not continuous, okay? So right at x equals 4, there's a hole, function is not continuous. So the answer here would be no. Okay, what about if they ask you, is f of x continuous on an interval? So this is saying, is f of x continuous between x equals -3 and x equals 0? So they want us to just look at this part right here of the function. They're only concerned with the space between x equals -3 and x equals 0. So they're telling you, ignore all the other parts of the function, just look at this specific interval. Is it continuous on this interval? And if we look at this interval, it looks fine, right? The function is defined everywhere. It has a limit everywhere. The limit values and the function values are the same. So yeah, on this interval, it is continuous. It's not continuous at x equals 4, but that's not what this question was asking. This question is just asking, on this specific interval, is it continuous? And so the answer is yes. On this interval, it is continuous. And then you might be asked a question, is f of x continuous? They might not give you a specific point or interval to look at. And so if they ask you this, what they're really asking, what's implied, is they're saying, is f of x continuous everywhere? Okay, so if you see this wording, if they don't give you a specific point or interval, what they're really asking is f of x continuous everywhere? And if we look at our picture over here, well, we know that there's a problem at x equals 4. There's a hole. It's not continuous at x equals 4. Therefore, it's not continuous everywhere. So the answer to this is no. So it's the same. You're going to use the same 3 criteria that we talked about, the same 3 conditions every time you're answering a continuity problem. But this part of the graph that you're looking at might be different. They might specify a point that they want you to look at, or they might specify an interval, or they might ask you to look at the whole function. So just read the problem carefully. But again, same 3 criteria every single time you're doing these kinds of problems, and memorize them. Okay, it's really, really important that you know those for the AP test and you can recall them and use them. So hopefully that was helpful. If you have any questions, make sure to leave them in the comments, and don't forget to like and subscribe. Thanks.